New Cartesian sign conventions for spherical mirror. For spherical mirror, we consider the pole of the mirror to be the origin of our coordinate system and the principal axis as the x-axis of our coordinate system. Then a line which is perpendicular to the principal axis and passing through the pole is our y-axis. So this is the Cartesian plane for the spherical mirror. Obviously, all the distances on the right side of the pole are taken as positive, and all distances on the left side of the mirror are taken as negative. All the distance above the principal axis are positive, and all the distances below the principal axis are negative. Then, as per the convention, we always take the object on the left side of the mirror. Object is always on the left side. This is a convention, not a rule. That means if we keep the object on right side, the image will be formed. But for the sign convention, we always consider that object is on left side. When we consider object on left side, that means the object distance is always negative. This is our object distance. So u is always negative. In case of mirror, the real image always forms on the same side as shown in this figure. So in that case, if the image is real, V is also negative. V is also negative. If you look at the focal length, if we take a concave mirror, you will see that the focus will be on the left side of the mirror, and for the convex mirror it will be on the right side. So if mirror is like this, then the focus will be on right side, and if we have a concave mirror, the focus will be on left side. So for the convex mirror, like this, f is positive, and for the concave mirror, f is negative. If the image is virtual, the virtual image forms behind the mirror, hence V will be positive for virtual images. If the image is virtual, then V will be positive. As far as the object height and image height is concerned, object is generally erect, hence object height h is generally positive. For real images, object height is negative because real images are always inverted, and for virtual images, h dash is positive because virtual image is generally erect. So these are the sign conventions that we follow when we do the calculations for spherical mirrors. The mirror formula is 1 by f is 1 by v plus 1 by u, where f is the focal length of the mirror, v is the image distance, u is the object distance. Magnification formula, m is equal to h dash upon h is equal to minus v upon u, where h dash is the image height, h is the object height, v is the image distance, u is the object distance. So these are the sign conventions of the spherical mirror, and based on these sign conventions we will solve some numericals. The first one is a real image 1/5 the object is formed at a distance 18 centimeter from the mirror. What is the nature of the mirror, and calculate its focal length. So the first statement translates a real image 1/5 of the size of the object. So image height h dash is 1/5 as that of the object. But image is real image is always inverted, so h dash will be minus 1/5 upon h, because h dash will be negative, image will be inverted. The reason for this is inverted image. So this you have to take into consideration while solving the problem. If they have given real image, then the image height will be negative. The size of the object formed at a distance 18 centimeter from the mirror. So image is formed on 18 centimeter. Again remember, image is real, so real image is formed on the same side as that of the object, and your V is also negative. So V is minus 18 centimeter. So this you have to consider. So sign conventions are very important. If you take sign conventions correctly, then and then only your answer will be correct. Now first we have to use the magnification formula. M is equal to minus V upon U is equal to H dash upon H, and from that you will get an equation which relates V and U together. H dash upon H, as you can see from here, your H dash upon H will be, if you transpose this H on left side, it will be minus 1/5. So H dash upon H is minus 1/5, and that gives you relation V by U is equal to 1/5, and that gives you relation U is equal to 5V, or V is equal to 1/5U, whatever. So this relation between U and V, then you can use the mirror formula, 1/f equal to 1/v plus 1/u. In that you can means put the value of V as seen here and U as seen here, and then you can calculate the focal length of the mirror. Second problem is, an object is 3 centimeter high, placed at a distance 9 centimeter from a concave mirror of focal length 18 centimeter. Calculate the position of the image form. This is a very straightforward question. So object 3 centimeter high, that means H is given. Object is generally erect, so you will take H to be plus 3 centimeter. Object is kept at a distance 9 centimeter. So object distance, which is always negative by convention, object is always placed on the left side of the mirror. So U is minus 9 centimeter. Focal length of the mirror is 18 centimeter. Mirror is a concave mirror, so focal length is minus 18 centimeter. And you have to calculate the position of the image. So very straightforward question. We should use formula 1/f is equal to 1/v plus 1/u. F is given here, U is given here. From that you can calculate V. So you can write 1/-18 is equal to, V is unknown, 1/v plus 1/-9, that gives you 1/v minus 1/9. So ultimately you get the equation minus 1/18 is equal to 1/v minus 1/9. Then you can transpose at minus 1 by 9 on the other side. So 1 by V is minus 1 by 18 plus 1 by 9. Then you can make the denominator same and find the answer, and from that you can calculate the position of the image. So next question, an object 5 centimeter tall is placed in front of spherical mirror. At a 20 centimeter distance from the mirror, a virtual image of 10 centimeter tall is formed behind the mirror. Find the focal length of the mirror and the position of the image, and then the type of the mirror used. Here also you have to read the question carefully. Object is 5 centimeter tall and the virtual image is 10 centimeter tall. What is the meaning of this? The meaning is that the image is magnified, and when the virtual magnified image is formed, image is virtual. Why it is virtual? It is given here, virtual, and we know that it is magnified. Then the virtual and magnified image can only be formed by a concave mirror. Remember, a convex mirror always forms a diminished image. A convex mirror always forms a diminished image. So if the image is magnified and virtual, the mirror has to be a concave mirror. And if the mirror is concave, then its focal length should be negative. So object 5 centimeter tall, so h is given plus 5 centimeter, is placed in front of a spherical mirror at 20 centimeter from the mirror. So u is given and you have to take it minus, because object is always kept on left side of the mirror. Virtual image 10 centimeter forms, so h dash, and you will take it is to be minus 10 centimeter because it's a virtual image, so it is an inverted. Really sorry. A virtual image is always erect. Virtual image is always erect. So h is plus 10 centimeter. Then find the focal length of the mirror and position of the image. So once you get this, again you will get a relation between V and U, that m is equal to minus V by U, that is equal to h dash upon h, and from that you will get the relation between V and U, and from that you can find F. An object is kept in front of a concave mirror of a focal length 20 centimeter. Image is 3 times the size of the object. So calculate 2 possible distances. Now here it's an interesting question. An object is kept in front of a concave mirror, so you know focal length is negative. So f is minus 20 centimeter. The image is 3 times the size of the object. So h dash is 3h, but also h dash can be minus 3h, isn't it? That means the image is either real or virtual. So the 2 possibilities are this. If the object is within the focal length of the mirror, then you will get a virtual and magnified image, and if the object is between F and C, then you will get a real and magnified image. So that is there. So you have to take 2 cases. So you will say case 1 and case 2. So case 1, h dash is equal to 3h, that gives you magnification m equal to minus V by U is equal to h dash upon h. H dash upon h is 3 here. So you get V is equal to minus 3U. Second case, m is equal to minus v by u equal to h dash upon h, and here h dash upon h is minus 3. So in that case you get v is equal to minus 3u, that is v is equal to 3u. So these are the two cases, and then you can solve accordingly. So if you take 1 by f is 1 by v plus 1 by u, you will get minus 1 by 20 is equal to we have to calculate u here, so means that equation must be in terms of u. So u is equal to minus v by 3. This you can take yes, we have to calculate v, so you can take u to be equal to v upon minus 3, that is minus v upon 3. So you will say minus 1 by 20 is 1 by v plus 1 by minus v upon 3, that is minus 1 by 20 is equal to 1 by v minus 3 by v. So like this you can, here you can take accordingly ki 1 by f is equal to, here u will be equal to v by 3. So 1 by f is equal to 1 by v plus 1 by v by 3, that is 1 by v plus 3 by v, minus 1 by 20 is equal to 1 by v plus 3 by v, that is 4 by v, and accordingly you can calculate. So here v will be equal to minus 80 centimeter, and here minus 1 by 20 is minus 2 by v, so minus will become plus, and accordingly you can solve. So like this, these numericals can be solved.